Hello friends, now we will derive the expression of pinch off voltage of JFET. The pinch off voltage is basically the gate to source voltage required for pinching off the channel. When the channel width becomes 0 here, that condition is known as pinch off condition. Now here if you see, the W is depletion layer width on either side of the channel, 2B is minimum width of the channel, 2A is maximum width of the channel. So when this 2B becomes 0, width of the channel becomes 0, and that condition is known as pinch off condition. We know we have derived the expression of width of the depletion layer in PN junctions. You can see my previous videos on PN junction diode. The width of the depletion layer of PN junction, reverse biased PN junction, is given by 2 epsilon by Q into 1 by NA plus 1 by ND into V0 plus VR whole under root. Na is the acceptor concentration, Nd is the donor concentration, that is acceptor concentration on P side, donor concentration on N side. V0 is the built-in potential, Vr is reverse biasing voltage of the junction. Here remember, the concentration of holes in P plus layer is very much greater than the concentration of donors in the channel. So therefore 1 by Na plus 1 by Nd is approximately equal to Nd, number 1. Number 2, the reverse biasing voltage across the junction is nothing but that is VGS. Therefore width of the depletion layer, either this or this you can say, that is equal to 2 epsilon by Q 1 by Nd into V0 plus VGS whole under root. This is the expression of this W, but it is twice. In fact, this is depletion layer on this side and that is depletion layer on another side. So one more thing, you can please see total width of the channel is, maximum width of the channel is 2A, and 2A is equal to, that 2A is equal to 2W plus 2B. This 2A is equal to this plus this plus this. That is the total width of the, maximum width of the channel rather I will say. So this W is equal to, that is nothing but A minus B. B is minimum width, rather 2B is minimum width, 2A is maximum width of the channel. So now this gives A minus B is equal to twice epsilon, you can put it here. So this A minus B will be equal to this divided by Q and D into V0 plus VGS whole under root. That's what you have. Now there is important relation here. You can see VGS is reverse biasing voltage. So for a reverse biased PN junction, remember VGS is much greater than V0. Therefore VGS plus V0, that is built-in potential of the junction, is approximately equal to VGS. So this gives what? A minus B is equal to 2 epsilon by Q into Nd multiplied by VGS under root. At pinch off condition, remember at pinch off condition VGS is called pinch off voltage and B is 0. Why B is 0? Because 2B is 0, this width, minimum width becomes 0, so B is 0. So this gives A equal to 2 epsilon by Q and D into Vp under root, or say this is equation number 1, this is equation number 2. Now you can please see here, pinch off voltage of the JFET is equal to, that is Q and D by 2 epsilon multiplied by A square. So where epsilon is what? Permittivity of the semiconductors. Q you know, and D is donor concentration. Now this is very important expression. There can be numerical in engineering services prelims or mains on this formula. So you should remember this formula directly. And from here what I conclude is Vp is proportional to what? And D directly proportional to what? A square, inversely proportional to what? Permittivity of the semiconductor. This is the relation you have. Say this is equation number 3. Although this is the final expression of the pinch off voltage, I will be talking about a small topic here. That topic is nothing but relation between A and B. We can derive the expression for relationship between A and B. Let us see that. This is what you have. See it carefully. What is Q and D upon epsilon? Q and D upon 2 epsilon is equal to Vp by A square, or you can say 2 epsilon by Q and D is equal to what? That is A square by Vp. Okay? So this is equation number 4. So from, if you derive the relation here, from equation first and third, what do we get? A minus B is equal to 2 epsilon by Q and D. 2 epsilon by Q and D is what? A square by Vp. So that gives A square Vgs by Vp whole under root, or this gives 1 minus B by A is equal to Vgs by Vp under root, or this gives the relation that is equal to B is equal to A into 1 minus Vgs by Vp under root. This is important relation which will be used for derivation of the drain resistance in ohmic region. So that from that point of view it is important. Otherwise you should remember this expression and this expression. These are important from understanding point of view. These are important from examination point of view. So this is all about the pinch off voltage of the JFET. In next topic I will be talking about the resistance of the channel in ohmic region of operation of JFET. So just wait for my next video. Thank you very much for watching the video.